looking forward to that. Always a pleasure to get a visit with some parents and talk about what we're studying and how you're doing and all that good stuff. And, or what you're not doing if you're behind. But just looking, I see like 8 people have not turned in part 2 of the test, and 9 people haven't turned in part 1. So, and we're already a week into the next module, and this was still from 2 weeks ago. This was due 2 weeks back, or a week from yesterday, actually. And some of you have not got that test turned in yet, which is showing in your grades, because this class has a lot of people that's going to have to be here on Wednesday. This is a B day Friday, so we will not have class on Friday. But right now I'm looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 people. Like almost half this class is under 70%. So you 15 people got to get some things turned in. I always tell people too, if you get your grade above 70% by Wednesday, I will count you present, because that's what the goal is to make sure you get everything turned in. And if you've got everything turned in, you're still below 70, you should come on Wednesday and let's talk about it and see what you need to redo and see what you're not understanding. But most of you are under 70 just because you've got zeros, because you have not turned in an assignment, and that'll bring your grade down below 70 very quickly when you don't turn in tests. So that's where you're at and need to get that turned in, guys. All right, let's take a look at what we got this week. Algebra 2, we'll go to our grade screen as usual. So go into our grade screen. Nice to see all your faces here this morning. You should have the first 2 assignments from Module 2 turned in already. So that's what was due. Yesterday was 2.01 and 2.02. If we look at this week in Buzz, we see 2.03 solving radical equations. Now remember, if you struggled on that first assignment, 2.01, you should probably go back and review that, because that's how we convert back and forth from exponent to radical, radical to exponent. And if you still can't do that, go back and review that first lesson. Go back and watch the class video on that. If you're still stuck, come see me, because we need to make sure you understand being able to go back and forth from an exponent to a radical. So we're going to be solving radical equations, and you have a quiz. So we'll look at the quiz while we're here, but there's no lesson to go with that because it's a quiz. So first 3 assignments here. So let's look at 2.03, and then we'll take a look at the quiz before we go. But see, we've got 2 more assignments next week. We have another assignment and the practice test after that. And then, man, we get to the 20th of October is when we're testing this. So you got a little time. If you haven't turned in Module 1, you've got all the way to October 20th to get it turned in. But don't wait. Don't wait to forget everything. Do it while you still remember something about systems of equations. All right, 2.03. There we go. All right, so we're looking at solving radical equations. So let's define a radical equation. That's a good idea. Although we haven't talked about solving any of them yet, but we've just talked about converting them back and forth to exponents. You can still see some in action. So the time it takes for a pendulum to complete one full swing, like a pendulum, like in a grandfather clock, or there's some just out there in some science buildings, have some big pendulums that just go and they move with the rotation of the earth. It's pretty cool. Going to one side and back can be found using this equation. T equals time equals 2 times pi square root of the length of the pendulum divided by 32. So there's a nice science equation for you to measure the amount of time it takes a pendulum to complete one full swing from one side and back to where it started again. So have you ever played with a yo-yo? Did you notice that the longer the string, the longer it takes to swing back and forth? Well, it just makes sense. It's covering more distance, right? If it's a longer string. That's the same concept as a pendulum. The longer the string, the longer it's going to take to swing from side to side. The shorter it is, the shorter amount of time it takes. So T represents time in seconds for one pendulum swing. L is the length of the string that the pendulum is being held on, or maybe it's not a string, it's a rope or a metal or whatever. 32 in the denominator represents the force of gravity on the Earth's surface. All right. After completing this lesson, we're going to be able to answer these questions. What reasoning and explanations can be used when solving radical equations, and how do extraneous solutions arise? Oh, there's an interesting word we haven't used in a while, extraneous. That kind of means it's not needed, it's extra, it's, yes, it's a solution, but not really. It's just, something else laying around. So, additional review on identifying radical equations. Let's take a look at that because we need a good review. All right, so let's look at what a radical equation is. This is a radical equation. The square root of x plus 2 equals 7. This is not a radical equation. X plus the square root of 2 equals 7. Because the square root of 2 is a number. The square root of x is unknown because it's a variable. So here's the difference. In the first equation, the variable is inside the radical. In the second equation, it's outside the radical. So a radical equation is defined as an equation containing a radical, that square root or third root or fourth root sign, where a variable is the radicand, which is the part that's underneath the square root or underneath the root, or the variable is part of. Maybe there's other things underneath there with the variable, but the variable has to be inside the radical. All right, so to make sure you understand that, square root of 3x equals 9, that is a radical equation because the x is underneath the square root. The square root of x plus 7, that is a radical equation, minus 2 equals x. X minus 2 equals 9. That's not a radical equation. That's just x equals 7, or x equals 11. I'm sorry, that's x equals 11. The square root of x minus 8 equals 1. That is a radical equation. X plus the square root of 3 equals the square root of 5. Well, the square root of 3 and square root of 5 are just numbers. So that's like saying x plus 1 equals 2. It's the same thing. It's just using different numbers. Not a radical equation. How about x times the square root of 5 equals 7? Well, again, the square root of 5 is just a number. That's not a radical equation just because it has a square root. This one is square root of x minus 11. So, yeah, it only counts as a radical equation when the x is part of, or any variable, could be a y, could be an m, whatever, is underneath the square root symbol. All right, so that was a little review on what a radical equation is. Here's a review on solving equations. And this is just how do you solve an equation? This goes back to Algebra 1. X plus 4 equals negative 7. You subtract 4 from both sides. X minus 5 equals 3. You add 5 to both sides. 4x equals 12 divided by 4. X divided by 8 equals 2. You multiply by 8. Solving equations is just simplifying it for x equals. When you get into squaring, like x squared equals 36, that's a little trickier. Because if we just want x and we've got x squared, we have to take the square root of both sides. The square root of x squared is just x. So then you have to take the square root of the other side, 36, which is plus or minus 6. Why two answers? Because 6 times 6 and negative 6 times negative 6 will both produce 36. So x could be either number. Right. So solving with squares and square roots, you got to remember how to do the opposite. All right, so there's little reviews on the front page. If you had an equation like the square root of x equals 4, to get rid of the square root, you do the opposite, which is squaring. So if you square the square root of x, you just get x. So x would equal 16 in this case, if the square root of x equals 4. All right. So when you square a square root, they're showing you how that works. It's really the square root of x times the square root of x because you multiply it by itself. So that's the same as the square root of x times x, which is just the x. So, all right. Oh, that's in my, I need to get that to go away. It's in my way. All right, next. Solving radical equations. Okay, here's where the fun gets. All right, it's time to apply this newfound knowledge to some examples. So let me get my pencil and paper here. Let's write this out. 5x plus 4 equals 7. All right, we're going to start with something relatively simple. Oh, that's a parentheses. There we go. It's just showing that everything is part of the square root, right? Not just the 5x, but the 5x plus 4 is all underneath the square root. It's all part of the radicand. So solving means we need to find out what x equals, right? We need x equals. That's what solving means, right? We need to figure out x. So the first thing we have to do is if we had anything that was not part of the square root, we need to move that. So we only have the square root on this side, but this question only has the square root, and this over here is everything without. So to get rid of the square root, we square both sides. Square both sides. So if you have the square root and you square it, that cancels each other out. It just equals 5x plus 4 equals 49, right? Because we take 7 and we square the 7. Okay, now we've got a nice simple linear equation that we solve all the time. Subtract 4. 5x equals 45. Divide by 5. X equals 9. Now, it's important, especially with radical equations, that we check our answers, because remember I said to it, sometimes we have extraneous solutions. We'll get to that. We're not there yet. X equals 9. So 4 times 9 plus 4 equals 7. That's what our original was. The square root of 5x plus 4 equals 7. So let's take our solution, put it back in and test it. 4 times 9. Oh, I'm sorry, it was 5 times 9. 5x. What did I write for? I was looking at that. 5 times 9 plus 4. 5x plus 4. I wrote the wrong number. 45 plus 4, because 4 times 9 is 45. So that's the square root of 49. So that checks out, because the square root of 49 is 7. It's also negative 7, but 7 is the correct answer. It does equal 7. So we can put 7 equals 7 there. All right, let's step through and see what they did on theirs, because they work right here. Isolate the radical. So the first thing you do is that has to be by itself, which it is. So then you have to square both sides. So this is a good place for the steps. If you're writing down the steps, want to know how to do this? All right, Jaden. If you're writing down the steps, want to know how to solve radical equations. Step 1, isolate the radical. We'll have some examples where we need to do that. We didn't have to in this. It was also already isolated. That was the only thing on that side of the equal sign. Step 1, isolate the radical. Step 2, square both sides. Once you get the radical by itself, then square it, because that gets rid of the square root. Step 3, solve for the variable. Now you've gotten rid of the square root. You just have a normal little linear equation or something along the lines. Use the proper, it says, oh, to solve a two-step equation, remember, you must use the reverse order of operations. First, you take the plus and minus and stuff and move that to the other side. Then you do the division and the multiplication after that. SAD map. I've never looked at it backwards like that. SAD map. And then the last step, check your work. Now we got to substitute it back in and make sure that worked, because sometimes we're going to see that it doesn't work. Let's look at another example. Oh, here's a good one. So let's do this one, because we talked about you have to isolate the radical first. Here's one where that applies. I've got it written down right there. So the first step it said was to isolate the radical. Well, when we look at it, this part right here is not part of the square root, right? That's not part of the radical. That is outside the radical. So we need to move that, minus 4. So now we have the square root of x minus 3 equals negative 3. Now we can square both sides. Square everything. So this becomes just x minus 3. Negative 3 squared. Negative 3 times negative 3 is 9. Add 3. X equals 12. Now let's check that. The square root of 12 minus 3, because I'm just substituting the x in, plus 4 more equals 1. So we had this solution, x equals 12. The square root of 12 minus 3. 12 minus 3 is 9. So the square root of 9 is 3 or negative 3, right? So if we use 3 plus 4, that does not equal 1. Negative 3 plus 4 equals 1. So this one works. This one did not work. So checking that, we had to use the negative. So let's look at our sample on that. Okay, isolate the radical. We move the 4 to the other side. Square both sides. X minus 3 equals 9. We came up with the x equals 12. And then when we checked it, like I said, the 3 plus 4 equals 1. This is an extraneous solution because since we had to go to the minus when we were checking, we don't do that. Anytime when we're checking, we only assume the positive. So when we had the square root of 9, that is 3. We know it also is negative 3, but we don't use that when checking. Checking our solution. Checking, assume the positive. So since this is 7 equals 1, no solution. And I should say it's actually extraneous. It is a solution because x equals 12, when we put in there, we solved it. We got to x equals 12. That's true. But when we put 12 back into it to check, it didn't work. So it's an extraneous solution. It's not a real solution. It's extraneous. This is an extraneous solution. So that's a word we'll be using in this unit, is extraneous solutions. Statement is false. There's no solution. It is called an extraneous solution. That's a solution to an equation that doesn't fit the requirements of the original equation. All right, let's look at their third example. Ooh, that one looks fun. All right, I'm going to write this one down. Square root of 3x plus 7 equals the square root of 19. They're like, oh my gosh, all these square roots, Mr. Brock. Well, remember, they go away real easy when we get to this step. When we get to squaring both sides, square roots go away. Okay, first step, isolate the radical, right? This one's already isolated. There's nothing extra. So we're ready to skip straight to step 2, where we square both sides. Square and square root cancel each other out. Square and square root cancel each other out. Nice. Solve for x. 3x equals 12. X equals 4. Okay, remember, now we got to check. We've got to put that back in there. Square root of 3 times 4 plus 7 equals the square root of 19. 3 times 4 is 12 plus 7. Oh, the square root of 19 does equal the square root of 19. This is the solution. It is not extraneous. Not extraneous. It is a real solution. Not extraneous. It's a real solution because when we checked it, the math works. Square root of 19. Square root of 19 is just a number. Let's look at that real quick because we talked about right here the square root of 19 divided by the square root of 19. Let me make it a little smaller again. I had it larger before because I was doing something else. Square root of 19. So if I do 19 and hit the square root button, that's what the square root of 19 is. 4.35889, 98, all this good stuff. Now, if I square that, I take that times 19 square root. So I take 4.3588, times itself, it equals 19 because it cancels each other out. When you have a square root and a square, it gets you back to what the original number was. The square root of 19 times the square root of 19 is 19. We just showed right there, it does cancel each other out. Square root of 19 times the square root of 19 equals 19. Like square root of 7 times the square root of 7 equals 7. Square root, square, cancel each other out. Square root of 25. Look, that one's one it's 5, right? Square root of 25 times the square root of 25. 5 times 5. What's that equal? 25. Square root of 25. So 5 times 5 is 25. So just showing you that mathematically works. The square root of 19 squared is 19. All right, so that's the 3 examples they have here. Important information about extraneous solutions that you must include in your work. Well, we definitely need to look at that. It's highlighted in pink and bold, got this big must. Let's see what this says. Notice in example 2, when checking our work, that the square root of 9 was taken and found to be 3. If we simplified that to -3, it would have worked, right? Because we talked about that. Because the square root of 9 could be -3, in which case -3 plus 4 equals 1, and 1 equals 1. That would work. But here's the thing. We're going to make an assumption that square roots will only be simplified to their positive integers. Otherwise, you will always get a solution that checks out one way and not the other way, right? Because if it's 3, it doesn't work. If it's -3, it does work. And that's going to be true with any of them. If it's the positive, it may work. If it's a negative, it's not. Or if it's a negative, it may work. The positive is not. That means there'd always be a solution that doesn't work. That's why we always make the assumption that we're going to simplify to the positive integer on square root. Only the positive. So that's only the positive integers. That's key when doing your check. When you check your work to see if it's extraneous, always assume the positive. Okay, here's more on solving basic radical equations. So they gave you some more examples. So I'll let you work through these. I'm not going to do them all in class here, but let's see. 3 times the square root of x plus 7 equals 12. Again, what's the first step? Isolate the radical. In this case, the radical is being multiplied by 3. So the first thing we need to do is divide both sides by 3 so we can isolate the radical. So it should be the square root of x plus 7 equals 4 because we're going to divide the 3, and 3 divided by 3 is 1, so that goes away. 12 divided by 3 is 4. So we have to do that step first to get just the x square root of x plus 7 equals 4. Then everything's the same after that. We square both sides. Oh, step 2, we've got we square both sides. So you've got x plus 7 equals 16. All right. And then the next thing we do, order of operations, reverse, get rid of the x by itself. X plus 7 equals 16. So we'll subtract, got x equals 9. And then finally, we have to substitute the 9 back in. 9 plus 7 is 16. The square root of 16, we're going to assume to be 4, not -4. And 3 times 4 is 12. So that is a solution because it checks out. So x equals 9 is a valid solution. All right. All right, here's 6 problems. Let's do 1 or 2 of them here. All right, the square root. In fact, you guys get notes and papers out. I'm gonna leave this up and let you guys pick which one of these 4 it's going to be. So let's try this one as a class. See if I can make it bigger on the screen just to make it. That's about as big as it's going to get. All right, the square root of 5x plus 11 equals 9. The square root of 5x plus 11 equals 9. So put that down on paper. There's a good chance to see if you know what we're doing and see which of those 4 answers would be correct. So work your steps. Isolate the radical, square both sides, solve for x, and then check it, see if it's correct. I'm going to write this down on my paper and be working it at the same time. 5x plus 11 equals 9. Square root of 5x plus 11. All right, I got my answer. I'm going to check it. All right, anyone got an answer yet? They give us 4 choices. X equals negative 1.6. X equals 4. X equals 14. X equals 18.4. All right. Did you get one of those 4 answers? If so, which one did you get? Put it in the chat. Daniel got x equals 14. He got one of those 4 answers. That's a good sign when you get one of the choices, right? If we get x equals 11, we're going, uh-oh. Mary agrees. She got the same answer. Let's select x equals 14 and submit it then. We've got a confirmation. Absolutely. Absolutely. If you struggled with that, I worked that right down here. Square root of 5x plus 11 equals 9. It was already isolated, so I could square both sides. Which means 5x plus 11 equals 81. Subtract 11, 5x equals 70. Divide by 5, x equals 14. Then I checked it. 5 times 14 plus 11. 5 times 14 is 70. So the square root of 81 is 9, and 9 equals 9. It did work with the check. So it's not extraneous. That's an actual solution. X equals 14. Here's one where you have to move this first, right? Because you can't, it's not isolated. You got to move the negative 2. And this gives you a possibility that it is extraneous when you get an answer. So I'm going to leave these others. There's 6 total. We did the first one together. But that's where you can go in and make sure you understand how to solve a radical equation. Because here they'll give you the answer if you're wrong. That's what you want. You want someone to help you if you're wrong, and they give you the answer. All right, let's look at page 3. Factoring. Yeah, you may end up with some quadratics. So here's a quick review of factoring. If we have x squared plus 2x minus 15, you can split that middle term, factoring by grouping. Say, well, if I rewrite the plus 2 as a minus 3 plus 5, minus 3 plus 5, because minus 3 plus 5 would equal 2, and minus 3 times 5 would equal the negative 15 that you have to have on the end. So after I rewrite it like this, then I can group it, the first 2 terms and the second 2 terms. So in x squared minus 3x, they both have an x I can factor out. In 5x minus 15, there's a 5 I can factor out. So that means now both terms have an x minus 3 can be factored. So now it's what's left is x plus 5, x minus 3. So there's 2 solutions. And that means you got to check both solutions. It could be both correct. Could be one of them is extraneous. It could be both of them are extraneous. All right. Oh, how many videos we got? 1 video. Let's watch this 1 video.
In this problem, you are asked to solve the square root of the quantity x plus 9 all minus 7 equals x. In order to isolate this radical, 7 must be added to both sides of the equation. Since 7 will be added to a variable, the result will be a binomial, x plus 7. Next, square both sides of the equation. Because there is now a binomial on the right side of the equation, it is important to note that the entire binomial must be squared, and not just the individual terms. Remember that squaring a binomial means distributing each term in the first binomial to each term in the second binomial. This problem looks different than the previous equations you have solved. The difference is two different x terms that cannot be combined, x squared and x. To begin solving for the variable, manipulate the equation so that all terms are on one side of the equal sign. This is the standard form of a quadratic equation. Ax squared plus bx plus c equals 0, where a and b are the coefficients on the variables and c is the constant. A quadratic equation is an equation with a degree of 2. The degree of the equation will tell you how many solutions there are. But how do you find those solutions? One way is by factoring. By factoring the trinomial x squared plus 13x plus 40, you will find two binomial factors. Set up two sets of parentheses which represent each binomial factor. The first term of this trinomial is x squared. The only factors of x squared are x and x. Therefore, those factors will be in the first term of each set of parentheses. For the second term in each set of parentheses, find the factors of 40, the last term, that sum to 13, the coefficient of the middle term. If it helps, design a chart similar to the one shown. Since 5 and 8 are factors of 40 that sum to 13, these are the two numbers that will be used as the second terms of the factored expression. In the past, when you solved equations, the variable was isolated on one side of the equal sign, while a number was on the other side of the equal sign. However, in order to solve quadratic equations, the equation must be set equal to 0. It is set equal to 0 so that the zero product property may be used. Therefore, in order for the given equation to be equal to 0, the factor of x plus 5, the factor of x plus 8, or both, must be equal to 0. All possibilities must be taken into consideration. If the binomial x plus 5 equals 0, then x equals negative 5. If the binomial x plus 8 equals 0, then x equals negative 8. Whew, that was a lot of work. But it was worth it because now there are two solutions, as indicated by the degree, that can be checked in the original equation. Since two answers were found, x equals negative 5 and x equals negative 8, both of these solutions must be substituted for x in the original equation to see if one or both of them are extraneous solutions. Don't forget to substitute these values everywhere you see the variable. As you can see, only the solution x equals negative 5 checked accurately. Therefore, x equals negative 8 is extraneous, and x equals negative 5 is the only solution.
All right, so we ended up with two solutions, but one of them had to be thrown out because negative 6 does not equal negative 8 when we check the solutions. That's why it's important to check. It's like the math works. Yeah, I got two answers. I got negative 5, I got negative 8. But for a radical equation, we may have to throw one or both out. It's pretty rare to throw both out, but it's very common to have to throw one or the other out. So that's what's important to check on that. So I was looking at that and I was like, that is really where you're going to make mistakes. You're going to make mistakes when you're trying to square both sides. Because they did this, they moved the 7 to the other side, right? And when some of you guys square this, you're going to say this is x plus 9 because you square that. And when you square this, you're going to say this is x squared plus 49. That is not this. What you solved was this. This is x squared plus 49. This is not. This is x plus 7 times x plus 7. That's where you have to be careful. When you have an x on both sides, this is where you're most likely going to make a mistake. You're going to do this. And from that point on, you're wrong. Because you're working with the wrong equation. You got to distribute that to simplify that all the way through. And it'll be the x squared plus 14x plus 49. You're going to forget that middle term. So you don't have that middle term. And that's going to throw your answer off all the way. So remember, when you have that, the way you solve that is you solve it like a quadratic equation. Move everything to one side so that it's equal to 0. And then you can factor it. You can use the quadratic formula, whatever way you like to solve quadratic equations, factoring by grouping, completing the square. Okay, I know nobody likes completing the square, but it's an option. And this is actually a square. We completed the square right there, x plus 7. That's x plus 7 squared. But once we move this x minus 9 over to the other side, that changes the entire equation. Or x plus 9. I'm sorry, that's an x plus 9. That changes the entire equation. But the video goes through that, a pretty good way of showing factoring by grouping. Or they just factored it. They just straight out factored it. They didn't even group it. So, all right. Here is squaring both sides of an equation again. Another review. 2 plus x equals the square root of 7. Looks pretty simple, but remember when you square 2 plus x, you can't square them separately. That would be 2 plus x times 2 plus x. So when you square each term, like if x equals 3, there's a good example. What if we substitute 3 in for x? If you squared each term, 4 plus 3 equals 7. But to show how it doesn't work, 4 squared plus 3 squared would be 25. And that would not equal 49. We're down here, if you put 4 plus 3 together, then 49 would equal 49. But make sure you square it correctly. Solving variables with radicals with variables outside. Remember, you have to move that negative 3. I mean, you got to subtract 3 from both sides. You got to move the 3 to the other side first. Subtract 3. Now you've got the square root of x minus 3 equals x minus 3. Now when you square both sides, make sure you do this correctly. That's where you're going to mess up if you're not careful. See, x minus 3 squared is x squared minus 6x plus 9. Then you move the x over to their side and the 3 over to the other side, and you end up with this quadratic equation right here. So then you need to factor that, which would be x minus 6, x minus 1. You can set this up. If you don't know, I need it to multiply together to be 12, and I need it to add together to be negative 7. So how can I get 12? I can get 1 times 12, negative 1 times negative 12, 2 times 6, negative 2 times negative 6, 3 times 4, and negative 3 times negative 4. And that's the only way you can get 12. There's no other numbers multiplied together to be 12. So it has to be one of these circumstances right here. So all of these meet the requirement where they multiply to be 12, but only one is going to add up to negative 7. So 1 plus 12, no. Negative 1 plus negative 12, no. 2 plus 6, no. Negative 2 plus negative 6, no. 3 plus 4, no. Oh, they got a goof right there. That's supposed to be negative 4. Negative 3 plus negative 4 is negative 7. They've got a blooper typo, but we would use negative 3 and negative 7. So then that's how it factors. X minus 3, x minus 4. So you solve those by setting them equal to 0. So you have a solution of x equals 3 and x equals 4. And then you have to check them. And in this case, 3 minus 3 plus 3. 3 minus 3 is 0, plus 3 equals 3. Over here, you got 4 minus 3. Well, 4 minus 3 is 1. The square root of 1 is 1. 1 plus 3, 4. Both of these solutions work. Because this one checks out to 3 equals 3. This one checks out to 4 equals 4. Both are valid solutions. Both are valid solutions. All right, here's our lesson summary. Steps to solving. So here it is, great for your notes right here. In fact, if you have a printer, you can just print this and put this in your binder for notes. Step 1. This is what you need to have in your notes. Steps to solving a radical equation. Isolate the radical. And here's an example you can have in your notes. Like I say, this is a great place to get notes. The lesson summary is perfect. After you isolate the radical, square both sides. Again, here's an example you can put in your notes. After you square both sides, solve for the variable. X equals 12. And then you have to check it to put it back in to make sure it's a valid solution and not extraneous. Not extraneous. Okay, here's 6 practice problems. Solve the following radical equations. Submit, see if you're correct. So let's work this one together because this is going to have x on both sides. So we're going to solve this one together. The square root of 2x plus 3 equals x. So the first step, remember, isolate the radical. Well, all of this is under the radical. So the radical is already isolated. So we can jump to step 2, which is squaring both sides. Okay, so when we square the square root, squaring the square root just cancels each other out. Just gives us the 2x plus 3. X squared, x times x, it's just x squared. So let's move everything to one side. I like working with a positive x squared. So let's move everything. Minus 2x minus 3. This side is now 0. This side is x squared minus 2x minus 3. We have a quadratic equation set equal to 0. We can use the quadratic formula. Well, let's use the quadratic formula. We don't do that very often. X equals negative b plus or minus the square root b squared minus 4ac over 2a. Quadratic formula. You can have that in your notes. You can look it up. It's available. Let's see. So our a equals just 1 because there's no coefficient out front. It's just a 1. B equals negative 2. And C equals negative 3. A, B, C, whatever the numbers are for x squared, x, and the constant. So our solutions are negative 2 plus or minus the square root of b squared. B is negative 2. B times b is 4. Negative 2 times negative 2. Minus 4 times a times c. 1 and negative 3. That's what a and c equals, right? 1 and negative 3. All over 2 times 1, because that's what a is. So we've substituted all the numbers. Now we just need to solve. X equals negative 2 is a positive 2 plus or minus the square root of 4 minus. What are we subtracting? 4 times 1 is 4 times negative 3 is negative 12. So 4 minus negative 12 all over 2. So x equals 2 plus or minus 4 minus negative 12. Well, that's 16 because a minus and a negative makes it a positive. So the square root of 16 is just 4. So that gives us 2 solutions. One solution is 2 plus 4 divided by 2. And the other one is when this is a minus, because it's either plus or it's minus. The other one is x equals 2 minus 4 divided by 2. 2 plus 4 is 6 divided by 2 is 3. 2 minus 4 is negative 2 divided by 2 is negative 1. There's our two solutions. X equals 3, x equals negative 1. If we'd have factored it, we would have found x minus 3, x plus 1, which would have been a lot easier in this case. But I wanted to play with this. We haven't done the quadratic formula very much at all. But yeah, negative 3 times 1 multiplies to be that. Negative 3 plus 1 adds to be that. So it would factor this, and we'd come up with the same answers. But we need to check. Okay, the square root of 2 times, let's take the 3 first. Extend that out, that covers all of it. Equals just x, which is 3. So 2 times 3 is 6. 6 plus 3 is 9. So that would be 3 equals 3. That's a good solution. This one's good. All right, how about negative 1? The square root of 2 times negative 1, make that longer, plus 3 equals negative 1. 2 times negative 1 is negative 2 plus 3 equals negative 1. Negative 2 plus 3 is 1. Square root of 1 equals negative 1. No, because we always assume the positive. 1 does not equal negative 1. This is extraneous. So we have one answer, 3. The other one is an extraneous solution. It's a solution, but it's an extraneous solution. We throw it out. X equals 3. See, it gave us both of them. So we submit that. Good job, because the other one we had to throw out, it was extraneous. More practice. All right. So anyway, there's 6 problems there. The next page also has some practice. Solve these. Submit to see if you're correct. Here's one. There's 5 you can practice right here. So once we solve this, which would be, let's see. X equals 9. Yeah. Excellent. Yeah. I didn't even test it. I did it in my head. But anyway, here's when you got to move the 4 first. But all right. So let's look at the assignment that goes with this. Given the equation, square root of 2x plus 4 equals 3. Solve for x, and is it extraneous? So the answer is either 4 or 5, and one of them is or isn't extraneous. Here's another one. Solve for x, and is it extraneous? Here's another one. Okay, here's a sample problem that someone else did. Eloise started to solve this way. She started with this equation. She added 3 to both sides to get this. Then she subtracted 1 from both sides to get this. Then she squared both sides, moved everything to one side that said equal to 0, factored that, came up with these 2 answers. And she said both of them were extraneous because when she tested both of them, neither one of them worked. What error did she make? Oh, that's a good one. Somewhere in there, she made a mistake. And then the last one, Violet was carrying around the steps to solve this. On her way to the math factory, great place to hang out, by the way, Violet dropped them and she mixed up the steps. So she doesn't know what order to do. She knows these are the 6 steps needed to solve this, but she doesn't know which is first, which is next, which one's after that. So here you go. AED, DBA, DAE, CEA. Some of these are steps from different problems. They got mixed together. So which 3 steps would solve this? All right, that's all of it. We got 5 questions. All right, I said I was going to look at the quiz because we also have the mid-module quiz this week. So this says, that's it. Just make sure you do this. Start. Let's take a look at this quiz. Rewrite this. Oh, that goes back to lesson 1. The first 2 questions are from lesson 1. The third root of x to the 8th power. Which one of these is that equal to? Okay, here's a exponent, rational exponent. Which one of these radicals is that equal to? Okay, here's the second lesson. Here's the question of the second lesson. Simplify this. What do we do when we have a power raised to a power? How do you simplify it? Which one of these is the answer? Oh, here's one to solve. This was from the lesson we just looked at. Solve this equation. And then here's one you have to work. Show all the work. It's worth 10 points. So if you don't show all the work, you're not getting 10 points. And here's the great thing, though. If you show all your work but get the wrong answer, you can get a lot of the points if what you were doing was right. It's like, okay, that was right, that was right, that was right. Oh, made a small mistake there, got the wrong answer. Okay, 8 points. Or maybe you made the mistake earlier and I'll give you half the points or something, But show me what you're doing. If it is extraneous, be sure to identify that. All right, now let me show you something here because this is where sometimes you struggle. If I'm putting this equation, square root of x minus 2 plus 8 equals x. Make sure you use this insert equation. Make sure you use this insert equation. So I can go down here to these symbols and say, okay, I want a square root. There's a square root symbol. Square root of x minus 2 plus 8 equals x. Okay, you see the problem between what I typed and what was on the screen? Let me make this bigger too. Here's what the problem was right up here. Here's what I typed in the insert equation. Notice how the negative 2 is no longer underneath the square root. And you're like, how do I make it stay under there with the x? It's not that hard. Here's what you do. Click on it. Everything you want, I can put a space there. Everything you want underneath the square root, put in parentheses. I said, I want the whole x minus 2. See, I put it in parentheses, and now look at it. It's all underneath the square root because I told it square root of everything in parentheses. So when I save that, now it looks right. Now I've got the x and the minus 2 underneath the parentheses. I know in some of the earlier ones we were doing the last week or two, people were struggling. They were trying to get the, there it is. They were trying to do like the square root of x squared. And they said, oh, look, the 2 is outside, but it's supposed to be underneath there with the x. You can fix that the same way. Put parentheses around the x squared. Oh, now look, it pulled it underneath the radical. See how the whole thing is underneath there now? It's all in the smart use of parentheses. I want everything included here to be underneath the square root because I put it in parentheses and that'll keep it together where it all stays underneath there. So I wanted to show you that so you'd know how that works. All right, I can shrink that back down forget about it. I love it, Rick. But that's it. 5 problems on the quiz. One of them you have to show all your work, which is to your advantage because, again, if you make a mistake somewhere, you can still get points. It's not all or nothing. Like multiple choice is all or nothing. It's either right or wrong. All the points, none of the points. Show your work. Okay, some of the points or most of the points, hopefully all the points. Don't forget to check your answer on that last one because you have to see, is this an extraneous solution? No solution because I had to throw that one out. Don't forget to substitute it back in for x and check your answer. Okay, guys, so 1 assignment, 1 quiz. So that gives us 2 things to do this week, but one of them's a quiz. So we only had 1 lesson. If you need to go back and review the first lesson or 2 before you take that quiz to make sure you know how to switch back and forth from an exponent to a radical or a radical to an exponent, that's huge in this lesson. If you can't switch back and forth, you're really going to struggle. Really going to struggle. So, all right, guys, you got about 25 minutes left in class. If you want to work on this, if you want to work on this assignment, if you get stuck, I'll be here. I'll be here in class for the rest of the class period. So you can start on that if you want to. If you got something else you need to do, that's fine too. But you've got the rest of class for your free time to get started on things. And I'll be if there's questions. But otherwise, have a great week. It is a B-Day Friday, so I'll be here Wednesday. But that's it. Don't forget Parent Teacher Conference.